All right, so then how is this going to help us as we're solving quadratic equations? Well, we want to see, first of all, can we get x squared all by itself? Let's try to add 15 to both sides. We're almost there. Divide by 2. So now we want to get x by itself. So we take the square root of both sides. Factor out the number 40 because it's not a perfect square. And I'm going to hit pause and just fill in the list. The biggest perfect square that I can see is 4. So we're going to use the pair 4 and 10. And then anytime you have a square root as a solution, you have two answers. You have the positive solution and you have the negative solution. So when we write this, after we simplify it all out, this is the same as the square root of 4 times 10, which is the square root of 4 times the square root of 10. Then square root of 4 is 2. So our answer is going to be positive or negative 2 times the square root of 10. And that symbol that I just drew means positive or negative. All right, let's look at another example. Everyone's favorite, fractions. So when you have a fraction on the outside, and now we are squaring a binomial, get rid of the fraction first. To get rid of fractions, you just multiply by the reciprocal. Reciprocal, refliprocal, see how they kind of sound the same? You flip it. And anytime you do that, you would multiply straight across. You'd have the same number in the numerator and denominator, so the fraction goes away. And that's what we want to happen. If you were to simplify 3 over 1, that's the same as 3 divided by 1, and that equals 3. So we are really taking 11 times 3, which is 33. And again, this whole section, we're trying to use square roots to help us solve. So instead of multiplying this all out, we're just going to take the square root of both sides to make the squared go away. We'll be left on the left-hand side with x minus 4. If we factor out the number 33, we don't have any perfect square factors other than 1. So we can't simplify this any further. It's just the positive or negative square root of 33. Then we want to add 4 to both sides to get x by itself. So this becomes 4 plus or minus the square root of 33. Let's try another one. Step 1, we want to get x squared by itself, so we add 8 to both sides. And then because it's x squared over 5, that's like x squared divided by 5, undo division with multiplication. Multiply both sides by 5. $120 is not a perfect square, so we're going to factor it. I'll hit pause again, and you'll see the list in just a second. Really big list, so you probably didn't need to watch me factor all that out. But you want to select the pair, because we have 1 as a perfect square. I can use the highlighter. You have 1 as a perfect square, 4 is a perfect square. And as I look up and down this list, I don't see any other perfect square factors. So we're going to select the pair 4 and 30. square root both sides. Perfect squares should be written in the front, leftovers should be written in the back. Square root of 4 is 2, so then our final answer, positive or negative, 2 square root 30. And it is both solutions, because anytime you're talking about radicals and square roots as a solution, you have both the positive answer and the negative answer. And again, that's what that plus sign over the minus sign symbol means. All right, one more example like this. So we still want to get the square part all by itself. So first we're going to add 6 to both sides. So 3 times the whole group x plus 4 squared equals 21. Divide both sides by 3. You get x plus 4 squared equals 7. Take the square root of the left side, take the square root of the right side. And then the answer is the positive or negative square root of 7. Not quite done because we still haven't gotten x completely by itself, so we need to subtract 4 from both sides. And when you write your solution, you should always have the rational number first. So negative 4 plus or minus the square root of 7. Last example, if an object is dropped, its height in feet can be modeled by the function, it should say h of t, equals negative 16t squared plus h sub 0. And h sub 0 is going to represent our initial height. So the question is asking what happens if we drop an object off a building that's 240 feet tall. How long is that going to take for the object to hit the ground? So first of all, we need to figure out what is our initial height. It tells us we're dropping an object off the roof of an apartment building that's 240 feet tall. So the initial height for us is going to be 240. We're being asked to solve for how long it takes the object to hit the ground. And if we're on the ground, we're not above it, we're not below it, we're at height 0. So h equals 0. Now let's substitute these values into the equation and see if we have enough. We have 0 equals negative 16t squared plus 240. Great, we have enough. We're trying to get t squared all by itself, so it's kind of up to you. There are a few different right ways to do this one. I believe what we would be most familiar with, let's subtract 240 first. Step 2, get the t squared by itself. Divide both sides by negative 16. After we divide, negative 240 divided by negative 16, we should get a value of 15. To solve, we're going to take the square root of both sides. So our answer, and I'll write it off to the left-hand side in purple, t equals the positive or negative square root of 15. For us, that's not a very useful measurement to say the square root of 15, positive or negative square root of 15. So we want to actually type that into a calculator. When we do, we should be getting a value that is close to 4, but not quite 4. So for us, when we type in the square root of 15, we should be getting 3.873. And the last thing you want to do for these type of equations is check for extraneous solutions. Time, it can't really, not in this context anyway, time isn't negative. It can't be measured negatively. So for us, that means it's going to take us about 3.873 seconds. All right, good luck. Let us know if you have any questions.